Hello, hackers. So, I'm going to be giving you a short, maybe not that short, of a guide video going over some scripting with Python just to kind of help you with any intricacies and maybe small things that can be a pain because cryptography is a lot of scripting involved and that can be a bit confusing to get set up and the speed at which you figure out how to get your script set up can help a lot because crypto tends to have a lot of challenges. All these AES, ECP, CPA challenges. There's a lot of loops, a lot of coding you gotta do, and I'm hoping I can help to make it easier. So I'm just going to go over different parts of Pwntools, what you'll find useful in the module or to use in this module, and kind of just explain how different things work. So just to start off, we have our first. We are on AES, ECB, CPA. So you have this when you run it, and you can choose an action for encrypting chosen plain text, for encrypting part of the flag, and you enter a choice. So I expect most people understand this. You have your process and you have your variable for it. And P.interactive basically allows it to be open in the terminal still. So if I were to go into this file and run it, then interactive mode just lets you interact with the Chash Challenge run file like you would normally interact with it, say like this. And the important thing is kind of understanding how to receive the bytes returned into a variable, because I think a lot of the confusing part is, say you could do action 1, give some data 1 2 3 4, and you get your result. You get all this output. You do choice 2, you choose index 0, length 1, you get all this output. And understanding just how to sort through that easily and quickly can be a big help. So first of all, we'll just want to start simple, send line. And when you're sending a value into the process, you always want it to be a bytes object because string objects can cause other issues and it'll give you annoying error output. And that's not a big deal, but just being consistent with sending in bytes objects in p.sendLine or p.send is going to be a lot more consistent. So we would do, say, byte string, and we do 1 for 1. And then we'll do our data. So we can do p.sendLine, and we'll do 1 2 3 4 again. Now we can stop that, run this one more time, and you'll see all this output, and then our results and our ciphertext from this 1 2 3 4 cipher, or 1 2 3 4 data. And then what you'll want to do is p.receive until is very useful. And it's going to basically remove everything before the receive until so that you don't have to worry about that. So we obviously only want to grab the ciphertext right here. So we're going to receive until this, the result. And we'll do byte string again. We'll do a colon and a space because we want to remove that space. And then you're expecting to only have the ciphertext. So we can do ciphertext equals p.readLine, and then we print that ciphertext. And we run that again, and you'll get this output. You'll notice there's a new line at the end. It's not necessarily a big deal in this scenario, but say in binary exploitation, when you want a memory address or you're reading in something, that new line can cause issues. So I tend to always add this -1 just to index that new line off. And then we just have our straight ciphertext. Now, moving forward from this, we can add p.sendLine 2, and we'll do, so for action 2, you have choice index length. So choice, our index is, we'll do 0, and then we'll do length 1. Now We do all that, and we get this. And once again, we just have to do the exact same thing. And if it is easiest, we can just do this. So what this will do is output our two separate ciphertexts. So our first ciphertext from encrypting our chosen plaintext, and then from encrypting the first index of the flag. And then we go to interactive. Now this is honestly a lot of what you'll be doing for cryptography is sending in values, and then the cryptography aspect is very much separated entirely from Pwntools. But there is later challenges, such as the base 64 one, where you might need to incorporate that. So you might need to do from base 64, if I remember. I believe in that. And you might need to use base 64 .decode, .encode to fix that and move around it. But for now, you really won't need to worry about it. So we'll move on. And what I think I will go over next is, one second. Oops, I'm messing this up. So let me open this and move on to the next part of our guide. And we're back. So what I will briefly touch on is some small aspects, which is, let's go over honestly, this is all you need for Pwntools in terms of cryptography. But let's say you're doing binary exploitation. You might need to be more exact with stuff. So I won't switch to binary exploitation challenge-wise, but I'll go over what it would end up looking like. So say you are grabbing, so say you are given a memory address, which is where you need some bytes to be. You know, you have your memory address on the stack. You would receive until maybe leak. And then you would do address equals p.readline. And then this would be our address. It could be, you know, whatever. It could be OX 1, 2, 3, 4, 5, 6, 7, 8. But this would be a byte string. So it would be something like this. And, you know, that can be confusing to work around. And what you, honestly, all you have to do is you can use int.fromBytes, and then you can turn that into a int and use it. And a second part of Pwntools that is incredibly useful, and I cannot stress this enough, you should use it, is the P64, P32 aspects of Pwntools. So if you're sending in bytes, or you have an integer and you want to send it in, you can do P64 and then you would do address. And so what this will automatically do is turn it into little endian. It'll set it up and make it work perfectly for you pretty much. You can also do 32 for 4 bytes, 16 for 2, and 8 for 1 byte. And so those are some of the useful things to use. Now, remember, send line versus send can cause issues. If you do send line, it will append a new line at the end. And in binary exploitation, that can be annoying and a pain because that's an extra byte. And sometimes one added byte at the very end is all it takes to mess everything up. So I would just pay attention to those small errors, those small things, because that can always cause issues and just be something you'll easily overlook. And then I think another aspect or another part of Pwntools to go over is specifically in process. If you need to add, say, let's see. So say you've /challenge run and you need to give it a argument like that. You can do it as a array, a list, and it basically adds them together. So you can do b/challenge/run. Or actually, I don't even think it needs to be a byte string. We can just do /challenge/run. And then you just do comma and 1, 2, 3, 4, 5, 6, 7, 8. Actually, that might need to be a string. But you can do it like that. And that will concatenate them together in a way. And basically, that works effectively the same as doing that. And it makes your life a lot easier. It's very helpful, very useful. And then for binary exploitation as well in specific, if you are running a script and you're sending in 72 bytes to fill the buffer, and then you have your memory address, so we could do p64 address, and say this is where the return address is, or you think that's where it is, but say you're not sure. What you can do is change this to gdb.debug, and then it'll run /challenge/run in GDB. And the second thing you can do is add triple quotes as a second argument to gdb.debug and add in automated commands for GDB. So say I want a breakpoint at main plus 10, and then we want to continue to that, and maybe we need a breakpoint at challenge plus 40. We don't want to continue to that yet, but maybe we want to print out the stack once we're at main plus 10, and then we want to go in one more instruction. We can do that, and that's our script. And every time we run this, it runs /challenge/run and automatically runs these GDB commands. Personally, I like to have everything tabbed in. I like to do a little debug mode, just makes life easier. You can do this, have a debug variable. Now, you don't need to do this exact thing. This is what I do. You don't need to copy me. But it's useful for just testing stuff because you can easily switch between the two, and you're not going to change what gets input to the process, and it makes life easier because if you run gdb/challenge/run, it's a pain to try and input this whole byte string again. But you can set up gdb.debug and it's all very chill. And I think there is another thing you would want to add, if only I could find it, which actually, here, I will make it appear. We will go and grab our second part. What I like to have for gdb.debug is wherever it is. Let's look for it. Where would I put it? Now, where would it be? It would be. Oh my gosh. It's nowhere to be found. Here. Is this. Okay. So I've made it appear. So are these two lines. Now, context.arch isn't really important right now, but if you're going back to say, well, computing 101, you probably don't even need that because you're inputting assembly files anyway. But what this does is when you're inputting assembly or shellcode, say, you have this, and Pwntools will automatically format the assembly you write into this architecture. So if you have like push, racks, pop RSI, all that, this will format it properly. And then we have context.terminal, which I find much more useful because what this does is it is basically telling the script to open a separate terminal for GDB. So it has two separate terminals running. But an important note is that this line will only work on your script if you're in desktop mode. If you're in VS Code, it won't work because it can't split it like it does here where it opens a separate window. It can't open a separate window in VS Code and it just errors out. So it can cause some annoyances. But instead, on the desktop mode, if you use this, you're in gdb.debug, you run your script, it'll show you the whole interactive section like this, and then have a second terminal with your GDB. And it makes everything super nice. You can look back and forth really easily. You can compare, and I find that it's a huge quality of life feature, and it speeds up the process of looking through GDB for binary exploitation a ton. It makes your life just tons easier, and it is a huge time save. And for some of these challenges or for some of these modules where they can get long, for cryptography you won't need it, but sometimes for binary exploitation, if you want to finish up, some last challenges, this can help to speed up that process when you're looking through it and trying to analyze what's going on. And then, since I've been talking so fast, I'll take a deep breath and chill, and I'll move on to talking about this. So, I don't think it might have been used in hijack to shellcode, probably, where you could do your shellcode and then you have your assembly like this. And so then you would have, say, pop rex, pop, push RSI, move RDI, OX, 1337, and so on, so on. Syscall. AMD64 as your architecture will tell Pwntools to format this in the AMD64 architecture. If you have it in ARM, it'll run in that. But you don't want ARM because it's not what will work. It'll break. So for this, it's not as important, but it's still useful. So you can include this, and then your assembly will be in the correct setup. It'll work properly, and then you can honestly then you would just do plus shellcode, and so you can just add that to your byte string that is getting read in. You don't even need to. I'm almost certain you don't even need to turn it into bytes. I could be crazy, but I'm almost certain you don't. There's a small likelihood you do, but I've used it so many times, I'm almost certain you don't. Either way, all of this, super useful. It is very helpful for just going through challenges much quicker. I would say that binary exploitation and cryptography take half the time required if you have a good understanding of Pwntools, because it makes your life so much easier for working through the challenges. For binary exploitation in specific, I would focus on the gdb.debug. That I find is exceptionally helpful. And then for cryptography, just understanding how p.receive_until works, how p.sendLine works, and whatnot, p.readLine. You want to make sure that your variables are always correct. If you're not checking what your variables before you compare initially, it could just cause so many errors. If you're doing ciphertext equals p.readLine, and then you don't print it and you get, say, flag ciphertext equals p.readLine from a separate section, and then you check if ciphertext equals flag ciphertext, but say your ciphertext, you forget to use p.receive_until, so it could equal something like result, while your flag ciphertext is, something like, that, and you don't have the result. It's never going to match, because the fact that this result's there, or you have a new line and you didn't have the new line here, and it's all good. But there's that new line, and that's going to cause errors because it'll never match. So I think it's important to stress the fact that you should always print your variables initially just to make sure they're the right values. It'll make your life a lot easier. It'll save a ton of time, and it'll just be a huge help. You should always double check your values before you should double check your values while you're running your script. So always print stuff just to make sure. You can comment it out later on once you've got everything figured out. But I cannot stress the importance enough of just making sure and double checking what you're doing. There's a lot of small things that can cause issues, especially making sure you're using byte strings, and then making sure you are avoiding that white space, because even a single space here could be a huge issue. That can mess up everything. if you forget to do result colon space. You do result colon, and you're going to have that extra space versus having a space and then just having your ciphertext. So I think that's basically all to go over. I'm happy to answer any questions and on topic if there's anything to clear up. But I hope this is useful, and good luck on cryptography and any Pwn College challenges. Goodbye, hackers.